Welcome back. Chapter 3, Section 3.3. Percentiles and box and whisker plots. Here, the focus points of this section is to interpret the meaning of percentile scores, to compute the median, quartiles, and 5-number summary from raw data, to make a box and whisker plot and interpret the results. Describe how a box and whisker plot indicates spread of data about the median. Okay, so let's understand what all these points mean. We have seen measures of central tendency and spread for a set of data. The arithmetic mean X and the standard deviation S. So arithmetic mean is X bar. Okay. So I better get the bar over here. All right, so there. It should be X bar, and the standard deviation S will be very useful later in work. However, because they each utilize every data value, they can be heavily influenced by one or two extreme data values. All right, both the mean and deviation can be influenced by one or two extreme data values. In case where our data distributions are heavily skewed or even bimodal, we often get a better summary of the distribution by utilizing relative position of data rather than exact values. So rather than just use X bar and S, we need a little more information. Okay, let's see what that means. Now, we know that the median is an average computed by using relative position of the data. So what was median? If you remember, you arranged your data values in increasing order. The middle guy is your median. If we are told that 81 is the median score on biology test, so suppose you took an exam in biology and your teacher said 81 is your median. So suppose you scored 81. What that means is 50% of the students were below you and 50% above you. That's what median means. 50% of the data fall below, at or below the median value of 81. Now, the median is an example of a percentile. Median is the 50th percentile. That means 50% are at your location or less. The general definition of the pth percentile is for whole numbers p. So notice you're looking at whole numbers p. P can go from 1 to 99. The pth percentile of a distribution is a value such that p% of the data fall at or below it. And 100 minus p percentage of the data fall at or above it. So 50th percentile means 50 or lower less, 50 or higher above. Okay, on the right. So here is 60th percentile. So that's 60th percentile. What does that mean? Out of 100 biology scores, look, that is 79.5. So how did we find 60th percentile there? Well, 60% of the data is here, right? So you add this. So I don't know what that is. Say that's a 5, 10, so on. You add these. 5 plus 10 is 15. 15 plus 15 is 30. 30 plus this is 30. So that's 60% of the data is before this. And 40% is therefore above it. All right. So that's 30 plus 10, 40. So this location gets me 60% below. That is, this is the 60th percentile. There are 99 percentiles. right? One first percentile, second until the 99th, and there is the highest score versus lowest score. If the number of data elements is not exactly divisible by 100, the percentile will not divide the data into equal parts. All right. There are several widely used conventions for finding percentiles. They lead to slightly different values for different situations, but these values are close together. For all conventions, the data are first ranked or ordered from smallest to largest. A natural way to find the pth percentile is then to find a value at which p percentage of the data fall at or below it. This will not always be possible. So we take the nearest value satisfying the criterion. It is at this point that there is a variety of processes to determine the exact value of the percentile. So here is the case. You see, if you added all the frequencies, you get exact 100. But if you don't have exact 100, say you added all these to get 150, then the picture would not be the same because you're looking at certain number out of 150. So a little more calculation is required. Okay, so where are we? So it's not always possible. You need to find pth percentile. Then you want to find a value such that p percentage of the data will fall at or below it. Okay. Regardless, this is not always possible, so we take the nearest value satisfying the criterion. It's at this point that there is a variety of processes to determine the exact value of the percentile. We will not be very concerned about the exact procedures for evaluating percentiles in general. However, quartiles are special percentiles used so frequently that we want to adopt a specific procedure for their computation. Quartiles are those percentiles that divide the data into fourths. Quartile, quarter is a fourth. So quartiles are those percentiles that divide the data into fourths. So here we go. You have a whole bunch of data starting from lowest to highest. Median is right in the middle. The first half, again, you've split it equally. So that is the median of the first half is your first quartile. Median of the entire guy is your second quartile. Median of the second half is your third quartile. So what did we do? We took the entire data, arranged it in lowest to highest. Here is the middle number, so that's 50th percentile. Middle of the first half is the first quartile, Q1. Therefore, median is the second quartile. Then one more quartile more, that gets you the third quartile. So this is the picture. Okay. All right. Several conventions are used for computing quartiles, but the common convention on the next page utilizes the median and is widely adopted. So, how to compute the quartiles? Order the data from smallest to largest. First, find the median. This is Q2. The median is Q2. Then the first quartile is the median of the lower half of the data. You're going to go below Q2 position and find its median, that is Q1. The third quartile is the median of the upper half of the data. You want to fall above Q2, so remove Q2 and look up and find the median, that is Q3, third quartile. All right. We'll come to this in our next video because I am afraid we are running out of, this video is getting too long. I'll come back in the next video. Until then.